This video is finding confidence interval for population variance.
Okay, a very good day. We are going to learn the confidence interval for population variance. The learning outcome is finding the confidence interval for population variance. Okay, the point estimate for the variance is a sample variance. Okay, mean the sample variance estimate the population variance. The sample variance, the symbol is a S squared. Okay, mean if we got our data y, actually we got the data, let's say from 1 up to n. Let's say n, you got 100 data, so 1 up to n. So each y, you can find their average, which is the bar y here. So each data of y, if you minus with the mean, okay, of the data y, later on you square it, okay, you square it, okay, divide by n minus 1. This is the variance, okay, this is a sample variance. Okay, what about the sampling distribution of S squared? Okay, for example, what would we see as a distribution of the S squared from repeated sample? Okay, if the observation yi are from a normal, okay, distribution, okay, where if the YR are from a normal distribution with the mean, mu, and standard deviation sigma, then the quantity, okay, of the sample variance, okay, you have a n minus 1 times S squared divided by the sigma squared has a chi-squared distribution with degree of freedom equal to n minus 1. Okay, the graph here shows the chi-squared distribution, okay, the graph of the chi-squared distribution, where when the degree of freedom 2, when we increase the degree of freedom, the graph become almost normal, where we see initially the chi-squared graph mean the chi-squared graph are actually non-symmetric, and it's a positive value, not like the normal and the t distribution graph where they are symmetric. Chi-squared and later on the f distribution are non-symmetric and positive value, and they depend on the one parameter which is degree of freedom. And to read the chi-squared table, depend on the new degree of freedom like t distribution table. Then how to find the confidence interval for population variance? Okay, if the n minus 1 S squared over the sigma squared has a chi-squared distribution, then we got the confidence interval in percentage will be 1 minus alpha, because alpha is a probability. Given the alpha probability, we are guaranteed that there's 1 minus alpha, then we time with 100% confidence interval that the variance will inside that in this interval, in this confidence interval. So to find 100 times 1 minus alpha percent confidence interval, we can find the upper and lower alpha over 2 critical value from this distribution. The confidence interval is 1 minus alpha, is actually the probability of our population variance of depend on the chi-squared distribution, chi-squared degree of freedom, which is depend on the degree of freedom, and then how to calculate degree of freedom just now, n minus 1, and then is 1 minus alpha over 2 up to the alpha over 2. For example here, let's say this is a degree of freedom 5. We got the alpha probability. So the confidence interval will be 1 minus alpha. If you want percentage, we time 100. So the lower confidence limit is calculated using chi-squared degree of freedom 1 minus alpha over 2. Upper confidence limit will be chi-squared df alpha over 2. Here. And then to get the variance, the confidence interval for population variance, we will swap like this in here. We had the formula, the population variance, the lower confidence limit will be n minus 1 s squared divided by chi squared df alpha over 2. Because alpha over 2 we have this alpha over chi squared df alpha over 2, remember, is here, alpha over 2, the value is bigger. 1 minus alpha over 2, the value is, this is bigger, so divide by bigger value, this will be smaller. 1 minus alpha over 2, the value is smaller, so divide by a smaller, we get the bigger value. For example, we got n is 7, so plug in n7. The bar y, the mean is 2.48, standard deviation is 1.13. Then we put up into this formula, n minus 1 will be 6, s squared, so we have time 1.13 squared divided by this value. So the numerator for both lower confidence limit and upper confidence limit are the same. And then we need to read from here. Degree of freedom, we got n is 7, so degree of freedom will be n minus 1, 6, 6, and then alpha over 2. We got my degree of freedom is 6. New. Insert the, can I insert anything? Degree of freedom is 6, and then my alpha over 2 is 0.025. We read the chi-squared table here, this chi-squared table. Degree of freedom 6, 95 confidence interval, so alpha is 0.05, alpha over 2, alpha is 0.05, alpha over 2 is 0.025. Yes, 6 here. So the value is chi-squared at alpha 0.025, nu is 6, the value is 14.449. Am I right? 14.449. So you see chi-squared 6 alpha over 2 bigger value, divide by bigger value, so you get this smaller value. And then this is chi-squared, degree of freedom 6, 1 minus alpha over 2. So mean 1 minus 0.025. 1 minus 0.025. So 1 minus 0.025 at the degree of freedom 6 will be 0.975, which is 1.237. 1.237. Then we calculate the lower upper limit divided by upper here upper confidence limit, so we get the population variance is between 0.53 to 6.193, where the s squared, if you calculate now here in s squared 1.13, you square it, you get 1.277. Here if you want to calculate here, 6 times 1.13 squared divided by 14.449, so you get here. So same thing with then the upper confidence limit is 1.237, 6.193. So mean the chi-squared value is used to calculate the confidence interval for population variance. So the conclusions here, the chi-squared is used to calculate for the population the confidence interval for population variance using this formula here. The left confidence limit is n minus 1 s squared divided by chi-squared degree of freedom, which is n minus 1 alpha over 2. The upper confidence limit, numerator are same, denominator is chi-squared degree of freedom, which is n minus 1, and then add the 1 minus alpha over 2. Okay, so with this, thank you for your attentions.